Okay, hey, welcome back, class. Today we're going to start on ionic bonding. So we've talked a little bit about chemical bondings. Now we're going to go into a specific type, which is ionic bonding. So before we dive in, let's just talk about our objective. Our objective for this video is to be able to identify and name ionic bonds. And saying that, let's dive in. Ionic bonds are chemical bonds that result from electrical attractions between cations and anions. So in other words, it's an attraction between a positively charged molecule and a negatively charged molecule. This occurs when a metal and a nonmetal bind together. That's a huge thing with ionic compounds. It has to be a metal and a nonmetal. What happens in ionic bonds is that electrons from one atom that wants to get rid of some of its valence electrons to fulfill its octet rule releases one or multiple electrons to another atom who wants to gain one or multiple atoms to fulfill its octet rules. This is typically a metal giving up an electron to a nonmetal. This results in a cation and an anion, so our positively charged particle, negatively charged particle, and thus creates a bond between them that's attracted by charges. Okay. Generally, these bonds have a high melting point. If we know from our bulk scale properties and intramolecular forces, if something has a high melting point, high boiling point, then it has strong intramolecular forces. That means it's very stable. Because it has this stuff, it's going to be a very strong bond. Okay, so these are very strong bonds and are honestly much stronger than your covalent bonds. So your ionic are your most strongest. So if we're getting anything out of this, we want to know that ionic compounds happens between a metal and a nonmetal. They happen when an electron is donated from the metal to the nonmetal, thus creating a charge differentiation, making them bond together. Okay, this is a very strong bond. So that's your main point so far. Now that we have ionic compounds, we know how to identify them between metal and non-metal and that stuff. We can talk about how do we name these things? How do we name these compounds? Well, we'll break the rules for naming ionic compounds into two sets of rules. The first type of ionic compounds are the ones that do not include transition metals in your metal forms. So it's just basically all the metals besides the transition metals. So remember, your transition metals is the middle portion of your periodic table. We'll go into the different rules for these transition metals in a minute and why we have to do these different rules. But for now, let's just get the basics. Okay, so we have a metal and a non-metal atom. We can immediately think it's ionic compounds, so we got to follow ionic bonding rules of naming and writing compounds. So our first step is to state the full name of the metal. So if I have sodium, okay, sodium and chlorine, then I would have to say the full name of my metal, which is sodium. Then my second step is to shorten my nonmetal and put the suffix "ide" at it, or IDE. So I would take my chlorine and I would shorten it and put "ide" in it, so it'd be chloride. So if I combine those together, then I would have sodium chloride. First step is to state the full name of the metal, then shorten the nonmetal and add the "ide" ending. Not too bad. Here are a few nonmetals converted into the "ide" ending so that you just kind of get an idea how this goes. So if we had nitrogen and we wanted to shorten it and put the "ide" ending to it, it'd be nitride. Oxygen would become oxide, fluorine would become fluoride, sulfur would become sulfide, chlorine would become chloride, and bromine would become bromide. Those are going to be your most commonly used nonmetals. So it might be good for you to keep a list of these somewhere. Now, we've gone over that part. We can now get into our transition metals. Our transition metals can have multiple oxidation states. So we need to be able to account for those oxidation states. So this is where our second set of rules come in for naming ionic compounds. We call this stock naming, but basically what you're going to be doing is using Roman numerals to identify what is the oxidation of that transition metal. Outside that, we keep the same rules. So if I have copper 2 and chlorine, I would call it copper 2 chloride, the 2 in Roman numerals. Okay, now, how do I figure out the oxidation number if I'm just given a chemical formula? Here's a nifty trick for it. So let's say we have CuCl2. Okay, what we're going to do is cross our subscripts to the opposite atom. So the 2, the subscript by the chlorine, is going to go up to the copper. And because there's no subscript by the copper, we can assume that it's a 1 because it's there. So that 1 is going to go up to the chlorine. So that's what that tells us is the oxidation state of each of those elements. So our chlorine is a 1 and our copper is a 2. So we're able to do a whole cross bit to be able to figure out the oxidation if we're just given the formula. So let's try iron 2 nitride. Okay, let's just work this, we'll work this both ways. Let's say we're given the formula. Okay, that would be Fe3N2. If I cross my oxidation numbers, my 3 is going to go up to my N. And my 2, my subscript 2, is going to go up to my iron, my Fe. Well, that's going to tell me that my iron's oxidation is 2. So if I want to write out the chemical formula for that, that's going to be iron, parentheses, Roman numeral 2, nitride. It's a big deal to keep the Roman numerals in parentheses. So we know that you're not just writing out some lines or something like that. It's not part of another word, and there just has to not be handwriting. The parentheses do matter. So let's say we want to work this the other way. If I'm given the words iron to nitride, how do I work this and find the formula? Well, I see I have iron and nitride's nitrogen. So first thing I'm going to write out is I have nitrogen's N and iron is Fe. Halfway there, we're good. Now we got to figure out our oxidation states for them. Well, fortunately, iron's a transition metal, so it gave us our oxidation state, iron 2. So I'm going to put a 2 up as a superscript by my iron. Now, I'm going to go look at my nitrogen. If I go look on the periodic table, it has an oxidation number of -3. So we're going to just drop the negative sign here, and we're going to put a 3 as a subscript for the nitrogen. Now, all we have to do is just cross them down to the subscripts. So now, the 3 from the nitrogen is going to go down by the Fe, and the 2 from the nitrogen, or the 2 from the iron, is going to go down by the nitrogen. So now we got Fe3N2. So we can see how we worked iron 2 nitride both forward and backward given either side. So that's just a quick breakdown of ionic compounds and ionic bonding. We're about to have some practice videos in a second so you can see how we work through these. Just wanted to kind of give you an introduction to the topic right here. And saying that, keep up the good work and see you next time.